In the previous video, I ran an experiment to collect the data shown now. Hello and welcome. This video will show you how to make the calibration curve for the Decagon 5TE soil moisture sensor. Shown now is a sample data table with 4 new columns: mass of water, dry soil mass, soil bulk density, and corrected volumetric water content. To find the mass of water, take the mass of the wet soil and container and subtract from it the mass of the dry soil and container. To find the dry soil mass, subtract the weight of the container from the total mass of the dry soil and the container together. I now use Excel's fill down function to fill in the rest of the data for the remainder of the column. To find the soil bulk density, take the mass of the dry soil and divide it by the volume of the soil sampler. Using Excel's fill down function makes it easy to reduce the time it takes to make these tables. And finally, to find the calibrated volumetric water content, divide the mass of water by the sample volume, which is equivalent to dividing the volume of water by the volume of soil, since the density of water at 20 degrees Celsius is 1 gram per cubic centimeter. When finished, plot a graph of the electrical conductivity versus the volumetric water content. Be sure to add a trend line and the equation in the options menu. This equation can be used for any 5TE probes that are used in the same soil used to generate this calibration equation, by plugging in the electrical conductivity for X and solving for Y to get the adjusted volumetric water content. If desired, you can plot a graph of the electrical conductivity versus the raw volumetric water content initially measured by the sensor. This plot can then be overlaid to the first graph, showing the differences that the calibration makes. A 5TE sensor properly installed in a normal mineral soil will have an accuracy of plus or minus 3% volumetric water content. This calibration is useful for when you need more accuracy than plus or minus 3%. Calibration is most often necessary when working with a soil with a very high electrical conductivity or non-normal mineralogy.